dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit. Now we will discuss the galvanic cell, and in the galvanic cells consist of two half cells. Each half cell consists of an electrode and an electrolyte. Both half cells may be used the same or different electrolyte. As we have shown in the diagram that there is a zinc anode and the copper cathode. So this type of half cell contains the one electrode and the electrolyte, and both half cells may be used the same or the different electrolyte. The chemical reaction in the cell involve the electrolyte, electrodes or an external substance, that is the hydrogen gas, as a reactant. That is in the case of the fuel cell. So in the full electrochemical cell, species from the one half cell lose electrons, that is the oxidation takes place, lose electrons because of the oxidation to their electrodes, while the species from the other half cell gain electrons, that is a reduction from their electrodes. So a salt bridge, that is a filter paper soaked into the KNO3, NaCl or some other electrolyte, is used to ionically connect two half cell. So with these two half cells are connected through the salt bridge. So these salt bridge which is having the different electrolyte. So each half cell, one having the different electrolyte and another having the different electrolyte, and they are connecting through the salt bridge, and that salt bridge maybe the filter paper is soaked into the KNO3, NaCl or the some other electrolyte. So but it prevents the solution from mixing the unwanted side reaction. So an alternative to a salt bridge is to allow the direct contact or the mixing between the two half cell. For an example, some of the electrolytes of the water, when we are using the water, so there we can just mix the two. So as electrons flow from one half cell to the other through the external circuit, a difference in the charge is established. So if no ionic contact were provided, these charge difference would quickly prevent the further flow of electrons and the cell will not work. So as electrons flow from one half cell to the another through the external circuit, a difference in the charge is established, means potential difference we will get, flow of the electrons we will get, and flow of electricity we will get. If no ionic contact were provided, these charge difference would quickly prevent the further flow of electron. So a salt bridge allows the flow of negative or the positive ion to maintain a steady state charge distribution between the oxidation and the reduction vessels or in the two of the half cells, while keeping the contents otherwise separate. So other devices for achieving separation of the solution are porous port and gelled solution. A porous port is used in the Bunsen cell. So there are various type of cell in which we can use the porous. So a half cell contains a metal in the two oxidation states. Inside the isolated half cell, there is an oxidation reduction, that is called the redox reaction, that is in the chemical equation. That's why it is a redox reaction, because there is a oxidation as well as the reaction takes place, and that is written symbolically by the M, that is M represent the metal, and in the two oxidation state inside the isolated cell, and there is a reaction takes place, and atom that has a charge imbalance due to the loss of n electrons, that is defined by the n electron. Now you can see that Mn positive oxidized species plus Ne negative, that will produce the N reduced species. Oxidation takes place, then a reduction takes place. So a galvanic cell consists of two half cells such that the electrodes of the one half cell is composed of the metal A and the electrodes of the other half cell is composed of the metal B. So the redox reaction for the two separate half cells are thus represented as An positive plus Ne negative, that is a ABM positive plus Me negative, means oxidation and reduction, that is equal to B. So the overall valence reaction will be written as Ma plus NBM positive, it will equal to NB plus NB plus MAN positive. So this is the various redox reaction inside the cell. So in other words, the metal atom of the one half cell are oxidized while the metal cations of the other half cell are reduced. So by separating the metals in the two half cells, their reactions can be controlled in a way that forces transfer of electrons through the external circuit where they can do useful work, means they can generate the electricity. So the electrodes are connected with a metal wire in order to conduct the electrons that participate in the reaction. In the one half cell, dissolved metal B cation combine with the free electrons that are available at the interface between the solution and the metal electrode B, and these cations are thereby neutralized, that causing them to precipitate from the solution as deposit of the metal B electrode, a process that is known as the plating. That metal will be deposited on the plate, that is known as the plating. So this reduction reaction causes the free electron throughout the metal B electrode. So the wire and the metal A electrode to be pulled into the metal B electrode. Consequently, electrons are vesseled away from the some of the atoms of the metal A electrode, as through the metal B cations were reacting directly with them. So those metal A atoms becomes cation that dissolve into the surrounding solution. So as this reaction continues, the half cell with the metal A electrode develops a positively charged solution, that is because the metal A cations dissolve into the solution. So while the other half develops a negative charged solution, that is because of the metal B cations participate out of it, leaving behind the anions. So this imbalance in the charge would stop the reaction. The solution of the half cell are connected by a salt bridge or the porous plate. Porous plate we can take. Why? That allows the ions to pass from one solution to the another solution, which balance the charges of the solution and allows the reaction to continue. So the anode is the electrode where the oxidation, that is the loss of electrons, takes place. Metal A electrode, in a galvanic cell it is negative electrode, because when oxidation occurs, electrons are left behind on the electrode. So these electrons then flow through the external circuit or to the cathode. So, while in electrolysis, an electric current drives electron flow in the opposite direction and the anode is the positive electron. So, the cathode is the electrode where reduction, gain of the electrons takes place, and the metal B for the metal B electrode. So, in a galvanic cell it is positive electrode as ions ions get reduced by taking up electrons from the electrodes and plate out. While in electrolysis, the cathode is the negative terminal and attracts the positive ions from the solution. In both the cases, the cathode attracts cation, and in both the cases the cathodes attracts the cations, and by their nature galvanic cell produce the direct current, means DC current we can get through the galvanic cell. Now, how we calculate the cell voltage? So, the voltage, that is the electromotive force produced by an galvanic cell, can be estimated from the standard Gibbs free energy change in the electrochemical reaction, that is E cell is equal to del R GOVEF. Now, what is this E cell? That we can calculate the where the V naught is the number of the electron transferred in the balanced half reaction, and what is F? F is the Faraday constant. However, it can be determined more conveniently by a use of the standard potential table that has been given. So, Faraday constant has been given from the standard table, the potential for the half cell involved. So, the first step is to identify the two metals and their ions reacting in the cell. So, then one looks up the standard electrode potential, that is the E node in the volts. For each of the two half cells, we can calculate the electrode potential, that is the E naught. So, the standard potential of the cell is equal to the more positive electrode potential value minus the more negative electrode potential value. So, whenever we calculate the standard potential, then we can get the positive value minus the negative value. So, for example, if we take out in the figure that CuSO4 and ZnSO4, zinc sulphate and copper sulphate, each solution has a corresponding metal strip in it. So, the salt bridge or a porous disc connecting the two solution and allowing the SO2 ions to flow freely between the copper and the zinc solution. Just to calculate the standard potential, one looks up the copper and the zinc's half reaction, and that will be the equilibrium reaction. So, equilibrium reaction where each half cell has a characteristic voltage. We depend upon the metal characteristics and its reduction potential. So, this half cell characteristics voltage depends upon the metal and the characteristics of the reduction potential. So, each reaction is undergoing an equilibrium reaction between the different oxidation state of the ion. When equilibrium is reached, the cell cannot provide the further voltage. It means when we are in the equilibrium state, then there is a not flow of any voltage. I mean, there is no exchange of electrons from one place to the another. So, in the half cell that performing the oxidation, the closer the equilibrium lies to the ions or atom with the more positive oxidation state, the more potential this reaction will provide. As we were closer to the equilibrium, so more positive oxidation state, the more potential we can get. So, the reaction will provide the more positive and more potential. Likewise, in the reduction reaction, the closer the equilibrium lies to the ion or atom with the more negative oxidation, higher the potential. So here we are having a two part, first is the oxidation and second is the reduction. In the oxidation, more positive, more potential, and in the reduction we are having the negative oxidation and the higher the potential. So what is the cell potential? Cell potential can be predicted through the use of the electrode potential, that is a voltage of each half cell. So these half cell potentials are defined relative to the assignment of 0 volt to the standard hydrogen electrode. So the difference in the voltage between the electrode potential gives the prediction of the potential measurement. So we can get the difference in the voltage between the electrode potential, that gives the potential of that cell. So when calculating the difference in the voltage, one must first rewrite the half cell reaction. So reverse the reduction reaction with the smallest potential to create an oxidation reaction overall positive cell potential. Half reaction must be multiplied by integrals to achieve the electron balance. So cell potential have a possible range roughly from 0 to 6 that you use in the laboratories. Whenever we perform the experiment, then we use the 6 volt 12 volt batteries. So cell using water based electrolyte are usually limited to the cell potential less than about 2.5 volt due to the high reactivity of the powerful oxidizing and reducing agent with water, which is needed to produce a higher voltage. So higher cell potential are possible when the cell use other solvents instead of the water. So for instance, lithium cell that is having the voltage of 3 volt are commonly available. Lithium almost the 3. So the cell potential depends on the concentration of the reactants, so as well as their type. So as the cell is discharged, the concentration of the reactants decreases and the cell potential also decreases, and it will not work and then there is no flow of current. So as the cell is discharged, the concentration of the reactants decreases and the cell potential are decreased, and it will not allow to flow electricity and generate, it will not generate the electric current. So electrolytic cell, that is also a one type of electrochemical cell that uses an external source of electrical energy to drive a non-spontaneous reactions. So a process known as the electrolysis. In this cell, voltage is applied between the two electrodes, similarly anode and the cathode. One is the positive and another is the negative, and that also immersed in the electrolyte solution. And this contrasts with the galvanic cell, which produces the electric energy from the spontaneous chemical reaction and form a basis of the batteries. So the net reaction in the electrolytic cell is a non-spontaneous, whereas in the galvanic cell is a spontaneous reaction. What is this non-spontaneous? Where the gives free energy is positive, that is a spontaneous. When that is a non-spontaneous, gives free energy is positive, that is a non-spontaneous, whereas the gives free energy is negative, then there is a spontaneous. So electrolyte or cell is a non-spontaneous, where the gives energy is positive, while the galvanic is the spontaneous, where the gives free energy is negative. You can see on the diagram that this is one type of galvanic cell. You are seeing that there are two separate system are provided. Now, what the principle of electrolytic cell? So, a electrolytic cell, a current pass through the cell by an external voltage, causing a non-spontaneous chemical reaction to proceed. In the galvanic cell, there is a process of spontaneous chemical reaction that causes an electric current to flow. But here there is a non-spontaneous chemical reaction. So, an equilibrium electrochemical cell exists in the state between the electrolytic cell and the galvanic cell. An equilibrium electrochemical cell exists in the state between the electrolytic cell and the galvanic cell. So, tendency of the spontaneous reaction to push the current through the external circuit is exactly balanced by the voltage so that no current flows. So, if this voltage is increased, the cell becomes an electrolytic cell, and if it is decreased, the cell becomes a galvanic cell. So, the voltage plays an important role. So, an electrolytic cell has the three component. Again the same, we are having the two electrodes and one electrolyte. The two electrodes, cathode and anode. The electrolyte is usually a solution of the water or the other solvent in which the ions are dissolved. So, molten salt such as sodium chloride can be the function of the electrolyte. And when driven by an external voltage applied to the electrodes, the ions in the electrolyte are attracted to an electrode with the opposite charges, where the charge transferring also, that is the redox or the Faraday reaction that takes place. Only with an external voltage of the correct polarity and the sufficient magnitude can an electrolyte cell decompose a normally stable or inert chemical compound in the solution. So, an electrical energy provided can produce a chemical reaction that would otherwise not occur simultaneously. So, Michael Faraday defines the cathode of a cell as the electrode to which cations, positively charged ions such as silver ions, flow within the cell to produce a reacting to just reduced by the reacting with electrons. It will be negative charge from that electrodes. Likewise, he defined the anode as a electrode to which anions, negative charge ions like chloride ions, Cl negative, flows within the cell to be oxidized by depositing electrons on the electrode. An external wire, that is a bridge between these two, in the galvanic cell forming a electric circuit. The cathode is positive and the anode is negative. Thus, the positive electric current flows from the cathode to the anode through the external circuit in the case of the galvanic cell. So, here we discussed the galvanic cell, and next is the primary cell. Primary cell, that is a non-rechargeable cell. Primary cell, one time use, then we can replace that cell. That is also referred to the dry cell. So, primary cell is a type of electrochemical cell that is designed to be used once and disposed of or discarded. So, after its useful life and its useful use, they lack fluid and inside, and hence referred to as a dry cell. They have a mechanism of the irreversible chemical reaction. Due to their high charge density, they discharge slowly. So, primary cell is not rechargeable and cannot be restored to its original charge. Once it has been depleted, primary cell are used in a wide range of applications, like you can see there are the various applications of the primary cell. So, in the next lecture we discuss about the other various cells like primary, secondary and fuel cell, that we will discuss in another lecture. Thank you very much.